Student, good morning everyone. In the last class, we have discussed about I have just introduced about the photoelectric effect. And in the last class itself, we have completed the Planck's quantum theory, right? So, dear student, here the photoelectric effect means in the last class itself, I have just introduced that concept or term. So, photo means light. So, whenever we expose our things, I mean, any chemical or any other things, then definitely what happens, the brightness will go. So why? Because of this photoelectric effect. So today we will go in detail about the photoelectric effect. In the last class itself, you might have come to know what is photoelectric effect, right? So in the today's class, we will be having a detailed study about the photoelectric effect. And dear student, this will be very important for minimum 2 marks, right? So keep this in your mind, right? So coming to the main concept of photoelectric effect, right? So already you know, if the sunlight falls on the surface of a metal or any other chemicals or any other substances, then definitely what happens based on its strength of a light, if it is more strong, then definitely more number of electron will be released. That means ionization energy, one we can say. If I mean the strength of that light is lesser or lower, then definitely one or two electron will be released from the what a surface. So that is nothing but the photoelectric effect. Photo means light. So coming to the main concept, photoelectric effect, particularly to the chemistry, then alkali metal shows photoelectric effect. First of all, alkali metal alkali metal shows photoelectric effect. So why these alkali metal shows photoelectric effect means, I will explain. So example, cesium and rubidium. So don't forget, once this question has asked among the following, which pair of the element can readily undergo into the photoelectric effect. That means you just remember alkali metals such as cesium and rubidium. So dear student, here see the element which loses the electron, those are called as what? Metals, right? And when the metal loses electron very easily when it has larger size. I don't want to go again in the detail of ionization energy, atomic size and all. Why? Because I have explained twice or thrice during the basic classes also, that concept we have completed, and during the offline for three days class, then also we had that in very detailed, right? So if the size is more, then definitely what happens, easily they can remove their electron from the surface. Why? Because the nucleus and the outermost valence shell electron distance will be more. So thus the nucleus will not be having so much strong bond with that particular electron. So that's why they can very easily undergo into the photoelectric effect. The first point is alkali metals shows photoelectric effect, and I have explained the reason also why they are showing, such as cesium and rubidium. A beam of light is passed through the surface of metal. A beam of a beam of light is passed through the surface of metal metal surface of metal, some amount of that means surface of metal, then the ejection of electron, then the ejection of electron then the ejection of electron takes place. This process is called then the ejection of electron takes place, then this process is called, sorry, takes place, the process is called photoelectric effect, right? Photoelectric effect. So the simple, very simple, they will ask you what is photoelectric effect. Then your definition should be this: a beam of light is passed through the surface of a what metal, then ejection. That means removal of electron takes place. Right? Sorry. Ejection of electron takes place. The process is called, or this process is called photoelectric effect, right? So what is happening when we apply a beam of light or we pass through the surface of a metal, then what happens? Some of the electron will be released or ejected from the surface. That particular phenomenon or this particular phenomenon is called as photoelectric effect. Very important, right? And see, when we apply beam of light, then the complete that energy will be utilized for ejection, or else it will be having some other right, that energy will be, see, my intention is to explain. See, what we are doing, we are passing a beam of light, that means we are passing the energy. So that means the total energy is utilizing for ejection only, or else the sum of the part is utilizing for ejection, and some of the part of that energy is utilizing for other thing, or what we will see in the next part. So when a beam of light with sufficient energy is passed through the surface of a metal, some amount of energy used to break metallic bond, and rest energy is used to increase the kinetic energy, right? So you will be having this point: when a beam of sufficient energy is passed through the surface of metal, some amount of energy, right? Some amount of energy used to break metallic bond. So metal means metallic bond only there. Some amount of energy will be utilized for breaking of metallic bond, and some amount of energy, I mean remaining amount, one we can say, amount of energy is used for increasing kinetic energy, right? So that means whatever the beam of light, that means beam of energy, whatever we are passing through the surface, it will not be completely utilized for the ejection. So in that 100%, some amount of energy will be used for breaking of a metallic bond. So that means if the electron combination is there in the metal, then we definitely say there will be a metallic bond. That means whatever the beam of energy we are passing, in that amount of energy, some amount of energy will be utilizing for the breaking of bond, and some amount of energy will be utilizing for the increasing the kinetic energy. What is kinetic energy? Kinetic energy is nothing but by virtue of motion, the energy which is produced by virtue of its motion. So that means whenever the motion increases, that is nothing but that means kinetic energy will also increases. So the moving body can produce what? Kinetic energy. The body which is in rest, which will not produce a kinetic energy. It is very important. So if the movement is there in the body, then definitely one we can say indirectly or directly that there will be a more kinetic energy is there in that particular what body, right? And diagram one we can show, right? If they ask you for the diagram, then definitely you can have this diagram, right? So sunlight, that means photoelectric effects with some sufficient amount of energy, then the ejection of electron takes place. Ejection, and this will be a metal, you can say alkali metal, and it is sunlight with sufficient energy, right? So whenever it falls on the surface of a what metal, then ejection of, right? So ejection of what electron takes place. So that means that process is nothing but what, whenever we apply sufficient amount of energy or supply sufficient amount of energy on the surface of a metal, then definitely there will be a ejection of electron, and thus that process is called as what, photoelectric effect. And with this help of this diagram, when we can explain what photoelectric effect. And so kinetic energy formula, I think you know. So kinetic energy is equal to, right? So work done plus W plus H into V. So that means kinetic energy is always work function. So that means where Ke is the kinetic energy, right? W is the work function. H is already we know Planck's constant, and V is sorry, it is not a V, it is nu. So nu, that is nothing but what, frequency, right? V is nu is nothing but frequency, right? So this is about what, kinetic energy. So based on this, after explaining some wavelength, frequency, wave number and all, we will be having some problems in the next class, right? After explanation of wavelength, frequency, wave number, right? So after that, definitely we will go towards what some examples, I mean calculation problem part is there. After explanation of these all concepts, then one we can move to the what problems, right? So dear student, today's assignment will be, you just write about the photoelectric effect in your own word, right? In your own word. So I want to know how you people are getting my class, right? So if you are getting or not, I can come to know. How, you repeatedly watch this video, particularly this video, and try to write in your own words, right? Add these all points, right? No problem. But your way of understanding must be introduced in those sentences.